Hello everyone, this is the 4.2 lesson and I have made a homework assignment to go along with this. It is comprised of the same questions that are in the unit quiz. It is linked to your study plan, so if you work in this assignment, you will be earning mastery points just like you would if you were in your study plan. So as you are working on these questions, some of the questions you would have had to answer over in the study plan will no longer be required if it is functioning as it's supposed to. So you might want to provide me with some feedback if you find that it's functioning differently than you expected, or if you like it. I always like to hear good feedback as well as constructive criticism. So we're going to see if this helps out, because from what I've lately been discussing with a few students, the unit quizzes sometimes are maybe not seeming like the best way to be able to navigate figuring problems out or reviewing or seeing over an overview of what is in the content. So we're going to see if this helps. Now I've been doing these kinds of assignments all along, but I've made them with less questions. I've been more selective about which ones I was doing, which sections I was providing. Some of them were pre-lecture assignments. So this will function pretty much like a pre-lecture assignment. It's meant to give you the content that will help you learn how to work the problems, in addition to whatever we've done in class or any videos that I've posted in YouTube. And that way, when you come to class, you have already learned a lot of the material and you're able to ask questions on the more challenging problems. But I'm going to go through a bunch of these problems also in this video, but I just wanted to start by introducing what these new assignments are all about. So you can see that I have linked media, similarly to how I've done things in the past, but I've just provided more media links so that everything is in one place. So this is all of the stuff that's offered by the publisher for this section. So you've got your applet, your PowerPoint, exponential functions, that's your textbook section, pencast videos, these are instructional videos made by the publisher. So in addition to that, I'm making more videos, but they're sufficient for the most part, so I'm just trying to supplement with additional, oh my goodness, there's a lawnmower outside my door, so I hope it's not too distracting. It's set up so that you have to open each one of these before you can access the questions. I've done it that way in the past with pre-lecture assignments, so you probably aren't too surprised by that. But you just need to open them to earn the point, although I'm expecting that you will actually watch them. If you don't know how to work the problems, you've got to watch these videos. That's the whole thing. And you can see that they've done all the examples in video format here. So all the examples that are in the textbook are actually covered right here. All right, so question number 1 here asks us to use the graph of y equals 5 to the x power to sketch the graph of f of x equals 5 to the x power plus 4 using techniques of transformation. So in a previous section, we learned how to apply transformations to basic parent functions, and this is the same idea. And I just want to remind you of this handout I gave you, which summarizes. In this handout, it starts off like this, and then there's all the basic parent functions and the reciprocal function. These are rational functions, and then you have the exponential functions right here on the left hand side, and then the inverses of those, the logarithmic functions, on the right here. So 4.2 is what these two are from. And if I go to the textbook, so I left blanks for you guys to fill in so that you would actually go and read the book. And so how do you get to the book? Well, I've showed you that in another video and in class a few times, but you can go to your multimedia library, also assigned media. You can get to your textbook from there. That's graphs of exponential functions. See, it's going to open up the textbook. Oh wait, that's an applet. So this one, which one is the book? That's odd. I know I assigned the book. The book is with the icon right here that looks like a book. You can click on that, and it'll open you up to, I'm not even going to reload it because I already did. Is it still open? Maybe not. Maybe it's closed now. Let's try opening it again. I tried to preload it before starting the video recording because it does take a few seconds to get going and then find your place. Okay, so this is what I was trying to say, is that if you want to fill in the blanks, you can just go to the book and figure out what's missing. But I don't spend a lot of time here because I feel like you learn more by actually doing the problems, and you can see the formal definitions and properties in the textbook. But one thing I want to point out is that you have certain points that are always on the basic parent function, and that would be -1, 1 over a. And what is a? A is the base of the exponential function. So you can see it here. Here it shows a to the power of x and 2 to the power of x. So in this case, this example, 2 would be a. So you should have the point -1, 1/2, as you can see it right here. 0, 1 is always on the exponential graph because anything to the power of 0 is 1. So no matter what the base is, you'll have that point. And then you have 1, a, positive 1, a, so 1, 2. So if you raise 2 to the power of -1, you get 1/2. If you raise 2 to the power of 0, you get 1. If you raise 2 to the power of 1, you get 2. So those are the points that are always on the graph. Now, if you have the reciprocal, or the reciprocal of the base here, see how this is 2 over 1? The reciprocal is 1 over 2. Now, when you have a flipped a base that is less than 1, it makes a horizontal reflection so that it flips across the y-axis, and you can see that everything's reversed here, right? So they're J-curves. They never go below the x-axis because you can't have an exponential to a power. You can't raise anything to a power and get a negative value. Is that true to say? No, it's only true for the basic function. If you have a base that is positive, then you will never be able to raise it to a power and get a negative. Yeah, that is true. All right, so but you can see that it's a is greater than 1 or a is between 0 and 1, meaning that the base for these functions is never negative. So that's another property that's important to note there. So you're either a fraction between 0 and 1, meaning a positive fraction, or a fraction that is above 1 and meaning greater than 1, so it's yeah. Okay, so top-heavy functions look like this, or top-heavy fraction bases look like this. They're greater than 1. Bottom-heavy fractions that are positive give you a graph that looks like this. So what do I mean by top-heavy or bottom-heavy? I mean, say the fraction 3 over 2, that's top-heavy. It gives you 1.5, so that would be greater than 1, and you would have a J-curve that looks like this. 3 over 1 is top-heavy. 2 over 1 is top-heavy. These are bases that are either an integer or a fraction greater than 1. And then if you have a fraction that is less than 1, meaning it's bottom-heavy, meaning that you're dividing the top is smaller than the bottom, so you're going to have a quantity that is less than 1 whole, and that's between 0 and 1. That's going to have the backwards j. But again, your base can never be negative, and therefore you can never raise a positive value to a power and get a negative, and that's the reason that your function stays above the x-axis. Now, when it might drop below the x-axis is if you add or subtract something on the outside of the function, because you can take this positive result and subtract a number from it that will make it drop down below the x-axis. So that's what we're going to review when looking at these problems with transformation. So this example says, use the graph of y equals 5 to the x to sketch the graph 5 to the x plus 4. Okay, so you can see we're adding something onto the outside. So whatever this y value would have been normally, we're going to raise it up by 4 units, which means the whole thing shifts up. So if you can recall that adding something on the outside of a parent function makes it either shift up if it's positive or shift down if it's negative. So I have to use my basic function as a starting point and then move it up by 4 units. Just shift the whole picture up by 4 units. All right, so I would start off by using the J-curve. Remember that you will always have the point 0, 1, and then you want to put the base. It already has the base for you. That's convenient. And then you're just going to shift this thing up, vertical shift of 4, right? We were adding 4 units. See, it's really very easy with this, the way that these questions are formatted, and it makes it so that you're not doing a whole lot of thinking. You don't have to plot points or anything like that. You basically just need to start off with your curve, and then it says right there the base is 6, already filled in for you, and then you're going to give it whatever kind of transformation should be applied. So you're really being tested on your knowledge of how basic functions are transformed rather than the full-on graphing techniques. So what was this one? We wanted 6x, 6 to, look at this one. Let me close this out for a second. 6 to the x plus 4. So now the plus 4 is actually in the exponential part, which means it's a horizontal shift. It's being applied to the x value. And remember that we move the opposite direction with this. So you might think, oh, plus 4, x plus 4, so I'm going to move 4 to the right. Actually, it's the reverse of that. You move to the left. So I'm going to start with my basic function, 6 to the x, and then I'm going to shift the whole thing 4 units to the left. Okay, so vertical, horizontal shift. I'm going to move 4 to the left. All right, then we have, what do we have next? Come on, load. Maybe I should pause the recording here. It's taking forever. Oh, okay, good. Use the graph of f of x equals 3 to the x to sketch the graph of f of x equals negative 3 to the x plus 1. All right, so 2 things are happening here. We're going to shift to the left. We're going to shift to the left 1 unit. We're going to flip vertically because we've got a negative on the outside of the lead coefficient. So I start off with my basic. And then I'm going to vertically flip it and horizontally shift it. So I'm going to shift it 1 to the left, and I'm going to reflect it across the x-axis, upside down. Then we have 10 to the negative x. Now notice, instead of the negative being on the front of the lead coefficient, the negative is in the exponent with x. So that is a shift across the y-axis, where we take our, if you had a positive x, now you're over on the other side with negative x, or vice versa. If you had a negative x, now the sign is changed and you're on the other side. So it flips this way. It flips, it's like a twist. It's like the turning of a page. So I'm going to start with my basic again, and then I'm going to y-axis reflect it, and that's all that was happening for this one. Yes, right. Then we have 2 to the x minus 2 plus 3. So 2 things happening here, a horizontal shift to the right by 2 units and a vertical shift up by 3 units. Start off with the basic. Let's do the vertical shift. I'm going to do what's doing vertical shift to the right. Up 3. Vertically up 3. Horizontally to the right 2. Okay, again, we have a horizontal shift to the left by 4 units and vertically down 3. Okay, down 3, -4. Okay, left 3, down 3. Left 4, down 3. All right, so this one, 1/4. Remember now that's a bottom heavy fraction, so it's going to be a backwards J. Wait. Of course, you don't even have to think of that because it's already putting the base in for you. Then we're moving to, we're doing a vertical shift down 2 units. Okay. And I think I've done enough of those kinds of examples, so I'm going to move on, see what else we have in here. There's just a lot of versions of these questions for more practice in here. The pooled quiz actually will not give you 25 questions. It's got a lot of the similar questions are pooled together.